So in this lecture, we are moving on to the fourth module, that is estimation. We are discussing about the main items of work which is necessary for calculating an estimate of a building. Before that, we need to know what is this cost estimation. So estimation, the word estimation refers to the calculation of the probable cost to construct a particular building. Okay, that is known as estimation. So cost estimation in a project management is the process of forecasting the cost and other resources needed to complete a project within a defined scope. Now there are mainly four principles for cost estimation. They are forecast, decisions and data, breakdown, basis of estimate report, etc. First one is forecast. Forecast means the major objective of this cost estimation is to forecast the quantity. How much, for example, if you have to construct a building, that is a farmhouse, if you have to construct, how much material is required, how much amount of bricks is required, how much amount of cement is required. So that amount you don't know exactly, but what you are doing is we are forecasting it. The amount of material needed for that and the cost incurred will be forecasted. So that is the first principle of cost estimation. Second one, decisions and data. So decisions and data is the second principle. It refers to this cost estimation just allows you to invest, um, take decisions on investments, alternatives and budget projections. For example, if you need um, an amount of 1 crore for the construction of a building, you have to um see how you could attain that much money. Okay, how, from where, if you have to take a bank loan or you have to invest some amount in a bank and take the interest for making the building within some stipulated time. So like that, what decision you should take, so that decisions are taken based on this um, uh, uh, in for this cost calculation. So that is the second principle, decisions and data. Third one is breakdown. Now after you getting that forecasted amount and the amount of quantity and the forecasted amount, then what you are doing is you will split up the work. There may be different works. For example, if you are constructing a building, you need to first construct the foundation. You need to first do the earthwork. You have to uh, dig a trench for the foundation, then you have to make the foundation, then you have to do the superstructure, then you have to make the do the masonry work, then you have to plaster it, paint it, make the roof, flooring, etc. So all the things you have to do. So what you are doing is you will split the work into different components. Then you can easily manage, for example, how much amount is incurred for foundation, how much amount is incurred for doing the masonry work, how much is used for painting, etc. You can do. Basis of estimate report is another important principle. So it is a report which is used to define the time, resources and money required to successfully complete a construction project on schedule and on budget. It is a report, how much amount is being spent on the work, how much time it will take, just like a contract. Okay, that is known as basis of estimate. So these are the four main principles of cost estimation. Now we are moving on to the main items of work. So I have already told you that if you want to construct a building, you have many steps to do that. First you have to dig a trench, then you have to make the foundation, then you have to do the superstructure masonry work, then you have to do that plastering, then you have to do the cementing, etc. Many works you have to do. So what are the items of work? So each of the work is considered as an item. Okay, so what are the items of work you have to include in an estimation? That we will see now. The first work is earthwork. Earthwork means before starting the building, constructing a building, you have to first make a trench to construct the foundation. So that comes under earthwork. So there are two types of earthwork. One is earthwork in excavation and the other one is earthwork in filling. Earthwork in excavation means we are excavating or we are digging the soil to make the foundation in it. So it is calculated. The unit is very important. Unit of each work is very important. In case of earthwork, we are taking the volume. How much amount of soil is taken out? How much volume of soil is taken out? That we will do. So that is calculated by length into breadth into depth of the foundation. Length into breadth into depth of the, not the foundation, the trench which we are making. So that is earthwork in excavation. Now what is this earthwork in filling? Earthwork is in filling is nothing but after making the foundation, we will fill the foundation with soil up to the plinth level. So plinth you all know, right? Plinth is nothing but it is the exposed surface of the foundation. So up to the plinth level, we will fill the foundation with soil. That is known as earthwork in filling. So in the first case, we were taking out the soil. In the second case, we are filling the soil. So in if you are doing the earthwork in filling, you will exclude a concrete in the floor, that is a 7.5 centimeter distance. Upside distance is reduced. Okay, for example, if you are making a foundation, in that after the foundation we will provide a flooring, right? Above the foundation we will provide a flooring. That flooring means we will provide some concrete, cement, and above that we will provide tiles. So that thickness is 7.5 centimeter. We will deduct that 7.5 centimeter. The remaining portions we will fill with soil. So this earthwork in filling is also calculated by cubic meters, that is meter cube of soil, length, breadth into depth. So this is a figure showing earthwork in excavation as well as earthwork in filling or plinth filling. Now the second work is concrete in foundation. So before concrete in foundation and soiling. So what we are doing is after making that doing that earthwork, we will first do soiling. In the below portion of the foundation, we will provide one layer of soil, one layer of dry brick or stone soil is provided. Okay, a layer of soil is provided. That soiling, the unit of that soiling is square meter, that is length into breadth of the foundation is taken. So that what soil will be filled. Now after soiling, we will provide a concrete. So foundation is made by concrete. A base of the foundation is made by concrete. So we will provide concrete over that. We'll place concrete over that. So that uh, amount of concrete is calculated by cubic meter. That is length into breadth into depth. How much depth we are providing the concrete, how much length, and how much breadth. So normally a thickness of 20 centimeter to 45 centimeter. Usually 30 centimeter thickness will be given for that concrete layer. Okay, and 1.1 is to 4 is to 8 or 1 is to 5 is to 10 concrete mix will be used. So after digging the foundation, we will provide one layer of soil over it. Then we will provide uh, what is it? After that, we will provide um a layer of concrete. So this is a figure showing that. Now after that, we will provide damp proof course. So damp proof is nothing but it is any material which reduces that moisture absorption, that is known as damp proof course. So we will provide, in most of the cases we will provide a damp proof course in around the foundation. So it is calculated in square meter, that is length into breadth. Area, in terms of area we will calculate the damp proof course. 2.5 centimeter thick rich cement concrete, 1 is to 1.5 is to 3, or 2 centimeter thick rich cement mortar, that is 1 is to 2, will be mixed with a waterproofing material. Some waterproofing materials used are normally Impermo or Semzil, etc. These are the materials. These materials will be mixed with the concrete mix or the mortar, and we will place it over the foundation. So that is about damp proof course, and it is calculated in area terms, that is square meter. So this is a figure of showing a damp proof course, a placement of a damp proof course. Now the next item is masonry work. So after forming the foundation, the base of the foundation and all, we will do the masonry work. So here in this figure you can see there is a foundation is there. Okay, a foundation is there. Here this is the foundation. A first footing is there, second footing is there, third footing is there. These are the up to the ground level we will provide certain footings for increasing the stability of the foundation. Then this is the ground level. Above that there will be an exposed foundation, that is plinth level. So this is the plinth level. This height is known as plinth height. Above that our superstructure, that is our walls of the buildings will come. So here we will provide the dam proof course. The dam proof course is provided to reduce the moisture absorption of the brick wall or the wall which we are providing. Okay. Now, moving to the masonry work, we have to provide masonry in foundation as well as in the superstructure. So up to this portion it is foundation, and above this it is superstructure. So the foundation and the plinth masonry, this is the foundation, this is the plinth level. This foundation and the plinth masonry, up to this portion the masonry work is taken as a single item, and above that we will have a masonry work for superstructure. Okay. So actually in this single item there are two items: masonry work for foundation and plinth, now then masonry work for superstructure. In foundation, since there are no openings in the walls up to the plinth level, we will not give any deductions. For example, if you're seeing a foundation, there are no holes in the foundation. We will not provide any holes, right? So there is no deduction. For example, if we need 100 bricks or 100 bricks, how much is the volume of bricks needed for making the foundation, we will take. No need of deducting anything from that. Now, if you are moving on to the superstructure, you know that if we are making a wall, we need to provide windows, ventilations, doors, etc. on the walls. So they are holes actually. In that portion, we are not providing any masonry work, right? So we have to deduct that particular area or that particular volume from the entire masonry work. So in superstructure, the volume of brick work is first calculated, assuming that there are no openings, and then we will deduct the door and window, lintel, etc. First, as a whole, we will calculate, then we will reduce the openings. And this masonry work is calculated in terms of volume, that is meter cube. So this is about masonry work. So if you are doing the superstructure masonry work, if there is a ventilation here, means the entire volume minus the volume needed for ventilation we will take for masonry work. So why we are calculating these quantities? We are calculating these quantities. There are a certain rate for all the quantity. For example, 1 meter cube of masonry work has certain amount of it costs certain amount. Okay, so if you know the quantity of masonry work which we are doing and the rate per unit quantity, then we can multiply both for getting the total amount expected. Okay, so that's why we are finding out the quantity of different items. Now the next work is reinforced cement concrete and reinforced brick work. In most of the cases we'll use reinforced cement concrete only. In some cases we'll use reinforced brick work. So these are nothing but we are providing steel members inside concrete for increasing the stability and for getting a, what is that, for bearing the tension. Okay. Now that RCC work is calculated in terms of volume, that is cubic meter, length into breadth into height is taken. Normally the quantities which we are taking in this case is floor slab, beam, lintel, column, foundation, etc. are included in this particular thing, because in all that cases we are providing some steel elements in it. So steel reinforcement and its bending steel are excluded from the quantity calculation. For example, if you are making a pillar with reinforcement, then what we will do is we will take the pillar as a single entity and we will calculate the RCC work for the pillar. Then we will subtract the amount of steel inside that. Okay, that is what we will do. That is how we will find the quantity. Now steel work. Steel work means inside the reinforcement we will provide steel members, right? This quantity of steel is calculated in quintal. For example, if we got and 0.6 to 1 percentage by volume of RCC or RV. For example, if we got 1 meter cube of RCC work here, then 0.6 to 1 percentage of that 1 meter cube will be steel. Like that we will take. That is how we will take the steel work. So this is about the RCC and steel work. The next item is foam work. So I think you know what is a foam work. Foam work, the cost of foam work is approximately 30% of cement concrete. How much is the cement concrete which we are using? 30% of that will be taken for calculating the cost of formwork. Normally it is the thing. Now formwork, the quantity of formwork, how much is the formwork we have to do is calculated in square meter. So I will show a figure. So this is a figure of a formwork. Formwork means the supporting elements which we are providing. If we are providing some reinforcement and all, the supporting elements which we are providing is known as formwork. For example, if we are providing a reinforcement here and something like a slab here, we will provide a supporting element made of wood or some other supporting elements which will make. That is known as formwork. And the horizontal supporting members are known as centering. If you are providing vertical members for supporting, that is known as shuttering. Centering and shuttering are two types of formwork. So the amount, these also are some, this formwork also will cost some amount, right? So the wood needed for this particular formwork have to be calculated. So that is calculated based on the amount of concrete which we are using. So the area of concrete is calculated because what we are doing actually, we are covering the area, right? So the formwork is calculated in terms of area. So that is about formwork. Now the next item is flooring and tiling. So after making the foundation, we have moved on to masonry work, then we have used the foam work, then we have to do the flooring and tiling. So flooring is calculated in terms of square meter, that is area of floor. How much area is there for floor? Floor means uh, this is floor. So how much area? So if this is a room, how much is the area of this particular room? That is the quantity of flooring needed. Now the base of the flooring is given by lime concrete. Normally lime concrete or some concrete mix will be provided at the base, and then floor finishing is given by cement, concrete, stone or marble, mosaic, tiles, etc. Okay, at the base we will provide cement concrete, lime concrete. Then we will provide cement or marble or tile or something like that. All are calculated in terms of square meter, that is length into breadth. Now if you are making a multi-storied building, in the first and second, in the ground floor it will be like this, base of lime concrete, and the top we will provide a finishing with marble, tiles, etc. If it is a first floor or the second floor, then what we will do is the supporting structure is taken as cubic meter. That is after the first floor, the second floor, if you're after the ground floor, first floor will come, right? So first floor will come above a slab, right? A roof slab will be there, which a reinforced roof slab will be there. So that quantity is calculated in cubic meter. Then above that we will provide the floor finishing. The floor finishing is given in square meter. Okay, so this is about the thing. Cushioning between slab and floor is given by lime concrete. I have already mentioned that. So this is flooring. Now roofing. Roofing is similar to flooring. It is also calculated in terms of cubic meter. Sorry, it is calculated in terms of cubic meter because we are providing roof slab here. Reinforced structure is provided here. Now lime concrete terracing finish is taken in square meter. If you are finishing the floor, finishing the roof, not floor, roof, then we will provide uh, uh, lime concrete for finishing it, and we will calculate the quantity in terms of square meter. We will provide a lime concrete at a thickness of 7.5 to 12 centimeter. Then after making the building, what we will do, we will plaster it. Plastering is nothing but we are providing an extra cement mortar over the masonry work for giving it a finishing touch. Okay, the plastering is measured in terms of square meter. Now in case of doors and windows, if you are providing doors and windows, at that portion no plastering is done. So what we will do is we will deduct the area for door and window from the total plastering area. Okay, plastering quantity of ceiling is measured as the area between walls. Ceiling, if we have a room and we have to calculate the plastering of the ceiling, ceiling means the top portion of the wall, we will provide the total area. That is the thing. Now normally the thickness of plastering is given as 12 mm. And some points we have to note before doing plastering. Openings not exceeding 0.5 square meter, no deduction or addition shall be made. If the openings, for example, there is a small opening, a small ventilation is there, then while calculating the cost we have to know the quantity of plastering, right? But there is a small ventilation and the area of the ventilation is less than 0.5 square meter, then you can no need of deducting that particular area from the plastering work. Okay, so like that some points are there to note how to deduct, where to deduct, and no, where not to deduct the areas. So that is about plastering. Now this is plastering. Now painting. After plastering we will finish the surface by means of paint. Paint is also measured in terms of area in square meter of the walls. 2 to 3 coats are provided. Whitewash, color wash or emulsion paints are normally given. Now after this, woodwork. Woodwork means we have to provide doors and windows and all. So in case of doors and windows there are mainly two parts. One is frame and the other one is shutter. So if you are providing frame, the area the calculation is based on cubic meter, volume of wood we will calculate. The volume is calculated. Frame means you know what is a frame. Frame is the outer portion on which the shutters are inserted. Okay, that door and window frame area, the total length of the frame is calculated by cross section. Total length of the frame, for example, if you are taking a window, what is the total length of the frame? Two heights. At the two sides there will be heights. Okay, right. So if this is a window, there are two heights, one here and one here, two. Okay, so the length of this height plus the length of this height, that these two are equal, so 2 into height, 2 into height plus 2 widths are there, 1 2, so 2 into width, 2 into height plus 2 into width will be the total length of the frame, total length. Now what is a cross section? That frame, each of the frame will have a cross section of a rectangle or a square. So each frame will have a cross section. So maybe 10 centimeter to 10 centimeter, like that some cross sections may be there. So into that cross section, that is this area into the total length will give you the total woodwork needed for frame. Now in case of shutters, shutter means the inside portion. This is the frame, inside is known as shutter, this portion is known as shutter. So multiplying height by breadth, you will get the total area. It is calculated in terms of area, not volume. It is calculated in terms of area. So this is about woodwork for door and window. So these are the different items we have to consider while calculating the quantity and the cost of a particular building. Okay, thank you.